Alright, good morning, students. I'm going to be teaching you technical drawing now that you're in Form 3, and I'm going to be making use of these PDFs, right, in order to give you the notes and for you to see how the construction is being done. I'll also be posting videos on YouTube. So the first topic that we're going to be looking at this term is reduction and enlargement. And the subtopic for today is reduction and enlargement of plane figures by length of sides. So for this topic, right, you have different methods of reduction and enlargement, right? And for this method here, right, notice that the heading is length of sides, right? That's something that you have to remember. So these two methods here that we're going to be looking at, right? The polar method and the direct method, they're used for reduction and enlargement of plane figures by length of sides, right? So in the future, if a question is set on the same topic here, and it asks you to reduce a figure or enlarge a figure by length of side, you should be able to know which method can be used for length of side. Alright, so that's important. So we're only going to be looking at one method today, and that method is the polar method. And this is the heading for the construction: to reduce a plane figure by length of sides using the polar method. And below that you have the measurements for the figure that we're going to be reducing, right, using the polar method. And the figure is irregular quadrilateral, right? And you have the measurements there: AB 45 mm, BC 40 mm, CD 30 mm, DA 20 mm, angle DAB 90 degrees, right? And it's going to be reduced in the ratio 3 to 5. So another very important thing to note is the ratio, right? Look at the ratio, 3 to 5. Usually when you're reducing a figure, right, or when you're working a question that's based on reduction, the ratio is always like this, right, where the first number is smaller than the second number, right? So you can see that the 3 is less than 5. And also in the PDF, right, there's everything there step by step for the construction. So if you need to copy the method in your book, you can copy each of these steps, right, as the method. So we're going to move on to the actual construction now. Alright, so first thing you're going to see me do here is draw line AB, right, for the quadrilateral, which is 45 mm. So the first thing we're going to do is construct this quadrilateral, right? And showing you how I construct this quadrilateral shouldn't be something I should be showing you, since you guys did construction of irregular quadrilateral in Form 2, right? So they are marking off angle DAB, which is 90 degrees, right? And I've done it with the protractor, but you could construct it if you want to, right? You don't need to use the protractor like that, like I did. Alright, for the next step, you can see that I'm taking 20 mm since DA is 20 mm, and I'm gonna mark that off on the 90-degree line that I draw there. Right, so that's how you get DA. Alright, next step you can see me taking the measurement 40 mm here, which is for BC, and you can see that I'm going to mark off that measurement from B, and then I'm going to take CD measurement, which is 30 mm, and from D I'm going to mark that off to intersect with that arc, and that where those two arcs intersect, that's going to give me point C. So now I can join B to C and C to D, and that's going to complete the quadrilateral. So now I'm going to choose a point P any distance away outside of the figure, and once I've chosen that point P, I'm going to connect it to each of the vertices on the shape, right? A, B, C, and D. So you can see me drawing it to A first, and then I'm drawing it to B, C, and finally D. Now, the next step here would be to divide PA into 5 parts, since the ratio being used for this construction is 3 to 5, right? So the last number, which is 5, is going to be used as the number for dividing the line PA, right? So if the ratio was something different, like 3 to 6, then 6 would be used instead. And dividing the line should also be something that I should not be showing you, since it's something that you did in Farm 1 and Farm 2. Right, but regardless, it's being shown to you here. So you see where that last line has been joined. I'm going to set my set square there, and I'm going to put my ruler at the bottom so I can slide it to draw the rest of the divisions, right? And then you're going to see me label each division 1, 2, 3, 4, 5. So now the next step would be to set your set square parallel to DA first, right? And you can see me marking off where the third division is. Since the first number in the ratio is 3, right? Remember the ratio is 3 to 5. We're going to slide that line to where number 3 is, right? Or to where the third division is. And whichever lines point A and point D is corresponding with, right? You're going to draw that line on the same place, right? So you're going to have A1 and you're going to have D1, right? And you can see the same line going through A1 is going through A, and the same line going through D1 is going through D, right? So they have to correspond, right? That's something important to note. Then I'm going to slide CD, right, to where D1 is, so that I can get point C1. So I slide it there, and then I'm going to draw my line so that it corresponds, right? The 2 points correspond, and that is going to give me C1. So now I'm going to transfer CB, right? I'm setting my set square parallel to CB, and I'm going to slide it to where C1 is so I can get point B1. And what you should be noticing is that the same lines going through A1 goes through A, the same line going through D1 goes through D, same line that goes through C1 goes through C. Right, so you can see that I've gotten the point B1 there, and all I need to do is connect A1 to B1, and that there is going to give you the reduced figure, right? That's how you get the reduced figure.